Notes 2.7. We're going to discuss cheat sheet number 4. Take a look at cheat sheet number 4. Maybe you don't want to take it out yet. Maybe you just want to follow along and pay attention and then look at it later. We have the right angle congruence theorem to kick us off. If two or more angles are right angles, then they are congruent. Yeah, no kidding. I think that's a pretty obvious one, but we have to have a name for all these things. We have to have a reason. If you have two angles that are right angles, then they are congruent. If you have three angles that are right angles, then they are congruent. If you have 10 angles that are right angles, then they are congruent. The kicker on this one is that it does have to say right angles. It can't say 90 degrees. If an angle is 90 degrees, then it is a right angle by the definition of right angle. If two angles are right angles, then they are congruent by the right angle congruence theorem. So please make sure that you're working with right angles, not 90-degree angles. I know it's a technicality, but it is a true technicality in geometry that you have to use. Congruent supplements theorem is coming next. If two angles are supplementary to the same angle, then they are congruent. We're going to do those on an example to make it a little bit clearer. But if you have two angles and they are both supplementary to the same angle, then don't those two angles have to be congruent? Let's say that angle is 30 degrees. Your other two angles are supplementary to it. First angle is 150 degrees. Second angle is also 150 degrees because they have to be supplementary to that 30-degree angle. If two angles are supplementary to the same angle, then those two angles are congruent. Detail-oriented theorem. What if two angles are supplementary to congruent angles? Then those two angles are still congruent. So instead of being supplementary to the same angle, they are supplementary to congruent angles. Same difference, the end result, the conclusion is that those two angles that you started with are still congruent. Not going to read these over word for word, but they are congruent complements theorem. Same thing as the two previous statements, only the word is complementary, meaning that they're going to add up to 90 degrees. Which then leads us to two things that we've already worked with, but more specifically the linear pair postulate. If you look on cheat sheet 3, we have a definition of linear pair. This is not the same. It's not the definition of linear pair. This is the linear pair postulate. Linear pair postulate says if two angles form a linear pair, then they are supplementary. The definition of linear pair does not have the word supplementary in it. Definition of linear pair just said two angles who make a straight line, or that share an adjacent side to make a straight line. But in this case, the linear pair postulate, which is underlined because you need to use that in your reason, it says if they're a linear pair, then you know that they are supplementary from there. And the vertical angles congruence theorem. Vertical angles, I didn't underline congruence theorem. If you do need to give a reason for vertical angles, I'm allowing you to just say vertical angles. But it says if two angles are vertical angles, then they are congruent. Again, not the definition of vertical angles. Definition of vertical angles is two angles that share a vertex whose sides make opposite rays. That's the definition. What is the vertical angles congruence theorem? If two angles are vertical angles, then they are congruent. Notice the if-then conditional statement again. So we're going to go to the congruent complements theorem, congruent supplements theorem. Take a look at this drawing, or draw it quick if you need to. The congruent complements theorem. Let me work with angle 1 and angle 3. It says, if two angles, got them, are supplementary to the same angle, if those two angles are supplementary to the same angle, well, if we look at it, angle 1 and angle 4 are supplementary because of the linear pair postulate that we just learned. If two angles form a linear pair, then they are supplementary. But also, angle 3 and angle 4 are supplementary because of the linear pair postulate. If two angles just so happen to be supplementary to the same angle, then those two angles, 1 and 3, have to be congruent. And in this case, that leads us right to the vertical angles congruence theorem. Of course vertical angles are congruent, but why are they congruent? Not because somebody drew a picture and said, hey, those are congruent. It's because of how the congruent supplements theorem works. If these are both supplementary to the exact same angle, then they have got to be congruent to each other. And when they're all set up as linear pairs like that, then they're all related and all connected to each other. It would work also if we set it up with complementary, but in this case I'm just doing congruent. We could have used angle 2 as well, and we could use numbers. If I wanted to say that the measure of angle 1 was 160 degrees, angle 4 has to be 20 degrees because they are supplementary. But then angle 3, because those are supplementary by the linear pair postulate, would have to be 160 because of those. But then angle 2, which is supplementary to angle 3, linear pair postulate, would have to be 20 degrees. So we're kind of proving vertical angles are congruent at the same time as using the congruent supplements theorem. Now, is it going to get a little tougher than that? Yeah, we'll throw some algebra in there. Okay, we've got 4x plus 2 for the angle on the top, 54 degrees over here, y minus 9 over there. Let's find x first. And to find x, we have to know that this is a linear pair, and linear pair are supplementary because of the linear pair postulate. So we're going to go 4x plus 2 added to 54 equals 180. Not sure if the assignment is going to ask you for a reason, but if you needed a reason, the linear pair postulate, have to write the word postulate, because it says if two angles form a linear pair, then they are supplementary. Go ahead and do the math here. You get 4x plus 56 equals 180. 4x equals 124. And x equals 31. Take that 31, plug it back in, just in case. Check and see. 4 times 31 is 124. 124 plus 2 is 126. 126 plus 54 is indeed 180 degrees. Okay, now we want to find y, and you've been taught this lesson before. Don't use y with 4x plus 2. We don't know what 4x plus 2 is. They didn't give us that information. But what we've just proven that if two angles are supplementary to the same angle, then those two angles must be congruent, as well as they are also vertical angles. So the vertical angles congruence theorem. So we can take y minus 9 equals 54, add 9 to both sides, and find out that y is 63. 63 minus 9 is 54 degrees. We have 54 degrees there. We had 126 degrees there, 54 degrees there. Why is y minus 9 equal to 54? Two reasons. You could use the vertical angles congruence theorem, or you could say if two angles are supplementary to the same angle, then those two angles are congruent. Either one would get you to that step. Last one, go ahead and draw angle C, angle A, and angle B, unless you have it on a handout. Given information, angle A is supplementary to angle B. And we could have just as easily done these same problems with complementary. I just stuck to supplementary on all of them. Angle A is supplementary to angle B. Okay, so we should be able to find x. Angle A is also supplementary to angle C. So we should be able to find y after we find x. Okay, let's find x. 3x plus 1 plus 32 equals 180. 3x equals, and if I want to take that 33 over here to this side, you would get 147. And x equals 49. If x equals 49, 3 times 49 is 147, plus 1 is 148 degrees. Now we don't have B and C as vertical angles, so we can't set them equal to each other. It'd be nice, but they're not vertical angles like they were in the previous diagram. So we're going to have to go with the fact that angle A is supplementary to angle C. So hoping that we got that problem right, we are going to take y plus 7 equals, plus 148 equals 180, supplementary. Y plus 155 equals 180. And if we take 180 minus 155, we get y equals 25. So we found x, 49. We found y, 25. We plug y back in, 25 plus 5. Oh, it's 32 degrees. We found x, we found y. Guess I could have left room down there. What can you conclude about angle B and angle C, even though they're not vertical angles like they were in the previous diagrams? In the previous diagrams, they were always set up as vertical angles, but even if they're not, you can still conclude that angle B is congruent to angle C, and your reason is if two angles are supplementary to the same angle, then they are congruent, which if you go back and look at cheat sheet 4 is called the congruent, yes, you can shortcut it, supplements theorem. Check out cheat sheet 4, the congruent supplements theorem. And yes, I abbreviated it by writing congruent as a symbol, supplements theorem. That's it. That's what you're going to be working on to try to do section 2.7. A lot of algebra involved, which for some of you is more fun. Good luck.